Let us do some examples on differentiation of log x and e raised to power x. It says that the diagram shows a sketch of the graph of y equal to fx, where fx is ln x upon x. As you can see that two functions are in denominator. One is denominator and one is numerator. It is fraction form, so we have to apply the quotient rule. It says that graph crosses the x-axis at point P and has a turning point at Q. We have to write down the coordinates, x coordinate of point P. Okay, it is asking for just the x coordinate and it is not asking for any differentiation and all. It is just said what will be the x coordinate of the point of intersection of the curve with the x-axis. That means by putting y is equal to 0, means y is equal to ln x upon x equal to 0, I will get the coordinate of x, right? That means ln x has to be 0 because this denominator cannot be equal to 0, so x has to be 1. Okay, so it is just 1 x coordinates. Then second part says find the first and second derivatives f(x), f dash x and f double dash x, simplifying your answers as far as possible, right? So let us differentiate this fx ln x upon x. So it is f dash x you will get by using the quotient rule. So this is x square, keeping x as it is, then differentiating ln x, which is just 1 upon x, minus keeping ln x as it is and derivative of x is just 1. Okay, so it is 1 minus ln x upon x square. Okay, this is first derivative. Now second derivative, again you have to find out. So second derivative is again applying the quotient rule. It is x raised to power 4. X square square is x raised to power 4. Keeping x square in the numerator as it is, differentiating 1 minus ln x is 1 minus 1 upon x. Okay, because derivative 1 is 0 and minus ln x is minus 1 upon x. Minus sign, keeping numerator as it is, 1 minus ln x, and differentiating x square, which is just 2x. Okay, so here you will get in the numerator as value minus x, minus 2x, and plus 2x ln x upon x raised to power 4. Okay, so f double dash x is minus 3x plus 2x. I can take out x outside and that x will be get cancelled with x raised to power 4. So I am just writing directly that it is 2 ln x. Here it is minus 3x, x we have taken outside, it is minus 3 and upon x cubed. Okay, this is your second derivative. Second part is over. Okay, let me write this, that it is your first part is this, just 1 comma 0. X coordinate it was asking, it is just 1. This is your second part, and third part says hence we have to show that x coordinate of point Q is E. Coordinate of x coordinate of Q means what is the point Q? It says that this Q is your maxima. Maxima will be obtained by putting f dash x equal to 0. So here I have my f dash x. So 1 minus ln x has to be put equal to 0. Okay, so 1 minus ln x is equal to 0. That means ln x is equal to 1. That says that x is equal to E, right? So hence we have proved that x coordinate of point Q is E in the third part. Okay, then it says find the y coordinate of Q in terms of E. So putting x equal to E back into the equation of the curve, I will get, as my function was ln x upon x, putting x equal to E, it is just ln E upon E. Okay, so ln E is just 1, so y coordinate is 1 upon E. So basically my point Q is E comma 1 upon E, right? We have to find out the value of double dash derivative at point E. So this is my f double dash x, putting x equal to e. So f double dash e is nothing but 2 into ln e minus 3 upon e cube. So it is ln e is just 1, 2 minus 3 is minus 1, so minus 1 upon e cube. Okay, now it is saying that use this result to verify that q is a maximum point. As we know that double derivative tells you about the nature of turning point. So if double derivative is positive, you have minima, and if it is negative, double derivative, if it is negative at the turning point. Okay, finding out the sign, finding out the value is not important as far as finding out the nature of turning point is concerned, but the sign of double derivative is more important. If sign is negative of double derivative, by putting the value of turning point in the expression of double differentiation, then looking up the sign. So if sign is negative, you have maxima. If sign is negative, positive, you have minima. So here the sign at putting the turning point, which is x equal to e, in double derivative, you are getting as negative. It is negative. That means point q is maxima, hence verified. Okay, and obviously as it is shown in the graph that q is a point of maxima. So here definitely the double derivative has to come out to be 0. Okay, next one. It is given that the curve y equal to x minus 2 e raised to the power x has one stationary point. Okay, stationary point, again we have to differentiate this, but in this case we have to apply the product rule as two different functions are in multiplication. So we have to find out the exact coordinates of this point. What point? Stationary point. And please remember here, we have to find out the coordinates. It is not just the turning point, means it is not just the x coordinate of the turning point, right? We have to find out the y value also. So let us quickly differentiate this function, which is x minus 2 e raised to power x. So y dash is e raised to power x, keeping second function as it is, and differentiating x minus 2 will give you 1, right? So 1 into e raised to power x is just e raised to power x, and then keeping x minus 2 as it is and differentiating e raised to power x, which is just e raised to power x. Okay, so y dash is taking e raised to power x outside. It is 1 plus x minus 2 means x minus 1. This is your first derivative. And as you can see, if we have to put equal to 0 to find out the stationary point, as you can see that this e raised to power x cannot be negative, or it cannot be 0, sorry. It will be 0 at x equal to minus infinity. Okay, as you can see that graph of exponential curve is like this. Okay, so e raised to power x cannot be 0. So we have only x equal to plus 1, which is your stationary point. Okay, so x equal to 1 is your x coordinate of the stationary point. So y coordinate is 1 minus 2 e raised to power 1, which is minus e, right? So coordinates of turning point is 1 comma minus e. Okay, these are the turning points, first part. Second part, it says that we have to determine whether this is maxima or minima. So as I told you in the previous example, that nature of the turning point or stationary point is determined by finding out the double derivative. So we have y dash as e raised to power x into x minus 1. So again differentiating this, keeping e raised to power x as it is, differentiating x minus 1, you will get 1, plus keeping x minus 1 as it is and differentiating e raised to power x. So you will get just one value, which is x e raised to power x, right? Now putting the value of the turning point is putting x equal to, in double derivative, putting x equal to turning point here was 1, which is 1 into e raised to power 1, which is e, and it is positive. So again, if turning point is positive, nature of this point will be minima. What point? Turning point. What is the turning point? 1 comma minus e. Right, so graph must be coming like this, right? It is a minima like this, and that point, turning point, is 1 comma minus e. Okay, so I think that's all for as far as differentiation of logarithm and exponential functions are concerned. Next topic will be differentiating trigonometric functions. Okay, till then,